The question was, do we really need a lot of protein to build muscle? Some of the largest, most muscular animals on Earth are herbivorous. To understand the answer to your question, you'll need to first distinguish between proteins and amino acids. There are 20 amino acids your body uses to construct proteins. Proteins are complicated things made up of, in some cases, thousands of amino acids. Think of the relationship between Lego bricks and fully assembled Lego sets. You can build lots of different things with the same basic components. Amino acids, the Lego bricks in our analogy, are classified into two types, essential and non-essential. Essential amino acids are ones your body can't produce. You need to acquire these somehow, typically by eating them. Non-essential amino acids are ones your body can synthesize from other substances. If you consume them, your body can make use of them, but it's fine if otherwise healthy individuals don't consume them. 8 of the 20 amino acids are essential for adult humans. 1 is essential for baby humans. The remaining 11 are non-essential for healthy humans. Amino acids are mainly comprised of carbon, hydrogen, oxygen, and nitrogen. This is important for later. Carbon plus hydrogen plus oxygen plus nitrogen equals amino acids. 52,000 or so amino acids equals protein. When you eat protein, it gets broken down into its component amino acids so your body can build whatever it needs to build at that time. Muscle repair after working out, for example. Imagine someone gives you a fully assembled cow made out of Legos. You break it down into the individual bricks and then reuse the bricks to make a hand. Some sources of protein have all the essential amino acids in similar ratios to what your body needs, some have all the essential amino acids, but in very different ratios, and others are missing essential amino acids entirely. For example, in humans, lysine is an essential amino acid. Rice is a decent source of protein, but it's rather low in lysine. If you just eat rice, you'll eventually become deficient in lysine. Incidentally, legumes have plenty of lysine, while being low in methionine, which is available in sufficient quantities in rice. If you eat beans and rice, you end up with a good balance, and healthy adults can meet their dietary needs for amino acids consuming them in sufficient quantities. Ruminants, the sort of large, muscular herbivore you're probably referring to, are a rather different story. They have similar, depending on which animal in particular you're referring to, amino acid needs, but meet them in a very different way. I'm simplifying here a bit, but essentially, they eat grass and other roughage, which then gets broken very far down into its basic components, importantly, among others, nitrogen, by bacteria in the rumen. The bacteria then take these basic components and assemble them into the amino acids and other nutrients the ruminant needs. The converted product gets sent on further in the digestive system, finally arriving at the true stomach and intestinal tract, which at this point is functionally a lot more similar to human anatomy. So the key difference is that healthy adult humans need to eat 8 essential amino acids in order to build muscle or, for that matter, much of anything else in the body. Ruminants can eat grass and similar substances, which get broken down and assembled into essential amino acids by symbiotic bacteria early in their digestive system, then sending those nutrients onto the rest of the digestive system. Cows, deer, elk, etc. need protein to build muscle and other cellular structures in basically the same way you do, they just have a special organ system filled with symbiotic bacteria turning what they eat, relatively useless grass, into useful proteins and other nutrients. A person who is not involved in any physical activity like sports or exercise should be consuming at least 0.8 grams of protein per kilogram of his/her body weight. Keeping it simple, one can aim up to 1 gram per kilogram of protein for his general health. That means if you're a guy weighing 80 kilograms and doing no activities, 70 to 80 grams of protein should be enough for you. When a person is involved in any physical activity, he puts his muscles to work, which causes their breakdown. Because of this, people who train or play need a bit higher protein intake than people who don't. An endurance athlete should be good with 1.2 to 1.4 grams of protein per kilogram of his body weight. This will ensure the net protein balance to be positive and he will not suffer from muscle loss. Resistance training leads to maximum muscle breakdown, and so more protein intake is required for recovering and for the muscles to grow bigger and better. We keep hearing that we need a lot of protein to build muscles. It is usually believed that you need a lot of protein to build muscles. However, it is not true. You can build muscles by consuming protein as less as 1.5 grams per kilogram of your body weight. A little more protein, say 1.6 grams, will give you even better results. The results keep becoming better when you go close to 2 grams per kilogram or even up to 2.2 grams per kilogram. Beyond that, consumption of more protein has shown to have a blunted effect on muscle growth. So, to optimize your muscle growth, you should be consuming anywhere between 1.6 to 2.2 grams per kilo of your body weight. But what if you are obese, or say you are at a higher body fat percentage? Most of your weight is just because of excess fat. This is why we consider the weight of lean body mass if your body fat percentage is high. Usually, if you are above 20% body fat, we consider lean body mass instead of total body weight. Example: a person weighing 80 kgs at 12% body fat can consume anywhere between 128 grams to 160 grams of protein if he is resistance training and wants to gain muscles. A person weighing 100 kgs at 30% body fat will only need around 118 grams to 140 grams, although he weighs more if he is resistance training and wants to gain muscles. The minimum dietary protein intake to stay just above nitrogen balance depends on age, gender, health status, glucose intake, the kind of protein, and probably dozens of other factors. Instead, ask how much you should allow to be safe. That only depends on age and gender. Young women on hypocaloric diets may benefit from as much as 1.6 grams per kilogram of body mass. Men over the age of 80 years may benefit from as much as 1.2 grams per kilogram of body mass. Everyone else needs only the commonly recommended 0.8 grams per kilogram not pound of body mass. They can eat more, and Americans average 1.2 to 1.5 grams, while young males consume more, like 1.6 to 2.0 without supplementation. Beyond some point, they just don't retain any more muscle. I mentioned the kind of protein. Complete animal proteins in the form of food digest slowly enough to be utilized by muscle. Very fast digesting proteins such as whey do not make muscle faster. Rather, a fraction of their amino acids temporarily saturate the small intestine, the bloodstream, and the muscles. What happens to the rest? No animal maintains a lot of amino acids in circulation to control osmotic balance, if for no other reason. That concentration is probably similar to the concentration of glucose, which would amount to 7 to 8 grams in the entire bloodstream. Concentrations above that won't magically become more muscle, but rather would be converted to glucose by the liver and stored as glycogen. Later, when the body needs amino acids for any other purpose, it gets them by taking apart the most recently deposited muscle. Another factor regarding the kind of protein is that a highly incomplete protein might not build any muscle at all, regardless of quantity. If a dietary protein entirely lacks a required amino acid, no muscle can be built and all of it becomes glucose. Vegetable proteins convert at comparable efficiency, ranging from 80% down to 20%. One cannot really balance plant protein sources by combining them. Vegetable sources are naturally so diluted by starches that it is difficult to consume enough of them at one sitting, and there is still never a perfect balance. The 7 to 8 gram limit mentioned above would prevent one from storing enough amino acids from one meal to combine them with amino acids from a different meal. It is probably safest to not count vegetable protein at all against the 0.8 gram standard. Don't believe the gym rats who claim they need a lot of protein. Some chug and count whey protein, which is almost completely wasted, thinking that they really need 200 to 300 grams per day. Others might make a similar claim after eating only vegetable proteins such as peanut protein that rate at a 20% conversion. It is also a big deal to consider the amount of muscle that we burn for energy. Amino acids can only be stored as lean tissue such as muscle. If one exhausts the 400 to 500 calories of glycogen stored in the liver, one will begin breaking down the most recently built muscle for glucose and then have to rebuild it later. Most actually cannot rebuild tissue fast enough regardless of protein intake, and lose a little muscle every day of their adult life. One cannot prevent that just by eating huge amounts of protein for energy because it may not digest at the rate that one needs glucose. It is safest to just consume enough starch, which digests rapidly to glucose, often enough to avoid emptying the liver. Let me repeat. One does not need the commonly quoted calorie surplus to preserve muscle between meals. One specifically needs a glucose surplus. All those factors confuse people into thinking that they need a large protein intake. Once one understands how much protein is just wasted, one can be comfortable with a much lower number.